So let us start. Let us start with the formal language. So a formal language is a language designed for use in situations where our natural language is unsuitable. For example, natural language is the language that we are speaking. So for our communication, whatever language we are using is a natural language. All of you know this. Okay, this is unsuitable in cases of mathematics, logic, the computer logic, whatever you have studied in MFCS, or in computer programming. There, the vocabulary that we are using, the notations that we are using, that everything is different. So that will not match up with the natural language. So we have introduced a formal language. So a formal language is nothing but a language designed for use in situations in which the natural language is unsuitable. So in these cases, we have designed a new set of alphabets. Okay, so this alphabet will contain a combination of letters which is forming a word. In our natural language also, a word is the major thing, right? So to form a word, we are making use of the letters of a particular alphabet. So that means entirely, freshly we are defining an alphabet and also a well-formed set of rules. A well-formed set of rules also we are framing. So that means we are making the help of an alphabet and a set of rules. Using these two, we will be designing our formal language. So let us see the example. So using natural language, if you see what is meant by formal and informal is, if I say the classes will start from August 3rd, so that is an informal communication. More formally, the same thing can be conveyed as the classes commences from August 3rd. So this is the informal and formal vocabulary in a natural language. Similarly, for end, I can say terminate. For try, we can say endeavor more formally. So like this informal and formal communication. So using the natural language, many times the human language, sometimes it will be informal, sometimes it will be formal, and sometimes it will be neutral also. So when you friends communicate, so neither it will be informal nor it will be informal. So according to your convenience, you share your chart. So it could be neutral also. So here we are morely focusing on a formal language. So as per our concern, so that is in case of a mathematics or in case of a logic or in case of a programming language, let us see what is meant by a formal language. So as I already told you, in formal language, we will be freshly defining an alphabet. Using those alphabets, we will define the strings, and using a string is nothing but a word. String are word one and the same. So these we will be using to form a particular language. So now let us see what is meant by an alphabet. An alphabet is nothing but a set of symbols. Alphabet is set of symbols. So these symbols, whenever you are forming it as a set, already you have the idea of set, right? What a set contains. Somebody answer. You can unmute yourself and answer. What is a set? Don't forget our social agreements. Yesterday we have agreed that we will not on our videos, but whenever a question is asked, you will unmute yourself and will speak. That gives me more interaction, right? A liveliness of the class will be there. Any of you can unmute and just give me the answer. What is a set? In mathematics, you know what is a set, right?
Ma'am, a set is a well-defined collection, ma'am,
Yeah, very good.
of distinct objects.
Okay, very good, Abdul. So a set always will have a uniform set of symbols in order to say a similar kind of symbols we will have or similar kind of elements we will have. So here Here also an alphabet is nothing but a set of symbols, but that set should be a finite one and it should be non-empty. So let us see the meaning of what is meant by finite. For example, so the alphabet is indicated with the letter sigma, right? So if sigma is an alphabet containing all the 26 characters used in English language, then sigma is a finite language. So it is finite and it is also non-empty because it is containing 26 characters in it. So it is a non-empty one and it is also finite. So I can call this as an alphabet. Similarly, instead of using sigma, you can use any character in uppercase. Here I am using capital X is equals to the set 0, comma 1. So here the elements of the alphabet or the symbols of the alphabet are 0, comma 1. How many elements I have? Two elements, which is a finite one. Since I have two, it is non-empty also. Both the conditions are satisfied. So I can call X also as an alphabet. And then if you see Y, so here we are the set Y is containing the alphabet Y is containing set of elements 1, 2, 3, so on. So I can't call this as an alphabet. The reason is it is infinite. Similarly, if you take Z, Z equals to empty set. This is also not an alphabet because it is empty. As per the definition, an alphabet should be a set of finite symbols and it should be non-empty. But here it is violating the rule, so I can't call Z as an alphabet. So next, so we will be making use of this alphabet to form a string. Other name for string is word. Both string and word one and the same. So in order to form a string, we will be using a finite sequence of symbols from some alphabet. For example, let us make use of the same alphabet that is formed out of all the English characters. Sigma is equals to A, B, C, so on up to Z. Totally 26 characters are there. So using these symbols, I can construct a string. So that the string that we constructed here is X, Y, Z. So this is a string over the alphabet sigma, which contains A to Z. And in strings, null string is also allowed. Here also similar to our programming languages, null string is allowed. So the empty string or null string is denoted by the letter epsilon. In mathematics, if it is an empty string or a null string, what will we say? If a set is an empty set, what is the symbol that we will be using? Yes, come on everyone, be attentive. What is the symbol we use in mathematics to denote an empty set? Waiting for your response.
Five. It is five.
Yeah, it is pi. Very good. So it is pi. But here we will be denoting it with epsilon or the null string. Epsilon is similar to the letter E, but the middle line, whatever is there, that we will be writing bit long. That is the only difference. I hope all of you know this symbol. Already you have used. So next, we have seen how to form a string. So now let us see what are the operations on strings. So the operations that can be performed is calculating the length of a string, concatenating strings, prefix, suffix, and substring. So totally 5 operations are possible. Already you know the length, concatenation, all these operations are known to you, but let us see how we will denote here. The length of a string is nothing but the number of symbols in that string. For example, W is a string, then its length is denoted using mod W. The same thing we use in mathematics also, right? Mod W. So in case of vectors, always to calculate the length of it, we will be using mod. The symbol for length of a string we are using is modulus. For example, if you take W, the string W is, why we are indicating with the W? W is saying a word. So a word W, word or string one and the same. W is A, B, C, D. So then the length of the W is indicated as mod W, which is nothing but 4. Totally 4 symbols or 4 characters are there in this. So the length is 4. Similarly, if I take one more string 010, so then this is also a string and then its length is 3. Similarly, epsilon. Epsilon is the empty string. Its length is 0. Whenever you are seeing epsilon, it indicates an empty string, null string. So the length of it is 0. Next, let us see how to form strings of various length using an alphabet. Let sigma be an alphabet and sigma is equals to a comma b. The alphabet is sigma. The symbols or the characters in this alphabet are a comma b. So now all the strings of length k is greater than or equals to 1 is denoted by sigma to the power of k. The length we are giving in the power, the k, sigma to the power k. So this k is indicating you what should be the length of your string. So more formally, we can write it as sigma to the power of k is equals to w, such that w is a string of length k. K is greater than or equals to 1. Let us see more examples of it. The alphabet that we have taken is a comma b. So now sigma to the power of 1. So that means it will contain a set of all strings whose length is 1. So we are writing only A. The length of this string is 1 character. Similarly, only B. The length of this string is 1. So here this set is containing two strings separated by A comma B. Next, if I say sigma to the power of 2, so it will, this set will contain all the strings of length 2. So that is AA, AB, BA, BB, all permutations of A comma B. Similarly, if I take sigma to the power of 3, so that means this set will contain all strings of length 3. You can use all permutations and combinations of AB. So 3A's, AAB, ABA, ABB, BAA, BAB, BBA, BBB. So these are the various strings that can be formed. Suppose if I won't say k greater than or equals to 1, what changes can be done to this? What extra string we will get? If I have not specified k is greater than or equals to 1, some extra strings should be added to each set. So first let us see for sigma to the power of 1. What extra string will be added? Any guesses?
Empty
Empty
string.
string, epsilon. Epsilon we will be adding, which is an empty string. Very good. So since there is a constraint here, k is greater than or equals to 1, we are not taking the null string. So now let us try to find out the length of this string. Okay, so that is indicated with mod sigma to the power of 1, which is giving you the number of strings present in that particular set whose length is of 1. It is 2, which can be expressed as 2 to the power of 1. Similarly, if you take sigma to the power of 2, so we are once again calculating the length of sigma power 2. So totally there are 4 strings AA, AB, BA, BB, which can be expressed as 2 to the power of 2. Similarly, sigma to the power of 3. So total number of strings are 8, which can be expressed as 2 to the power of 3. So from this, let us try to generalize a formula. So the length of the number of strings that will be there in a particular set can be given as 2 to the power of k. So mod sigma to the power of k will always give you the length of, so the number of strings of a particular length. Let us see for this example. S equals to 0, 1, 2. So totally I have three symbols in the alphabet S, and then S square. So that is indicating you the string length of 2. So this set will contain all the strings of length 2. So you can use all the various permutations and combinations of 0, 1, 2. So the strings that are formed are 0, 0, 0, 1, 1 second, 0, 0, 0, 1, 0, 2, and then let us start with 1, 1, 0, 1, 1, 1, 2, and let us start with 2, 2, 0, 2, 1, and 2, 2. So these are the various strings that are possible. So now if you apply the formula mod s to the power of 2, so that is s is not, what is length of s? Totally 3, 0, 1, 2. So 3 to the power of 2, which is nothing but 9. So why we need this formula is, suppose if an alphabet is given to you and if you are asked to write all the strings of that particular alphabet, so then you can verify whether you have got these many number of strings or not, or have you missed anything. So you can verify with the help of this formula, that is mod sigma to the power of k. The next operation that we can perform is concatenation of strings. So this also is a known operation to you. If W1 and W2 are two strings, then concatenation of W2 with W1 is a string, and it is denoted by W1 dot W2. So you need not specify any dot, you can write it as W1 W2, and also the length of it, mod W1 W2 will be equal to mod W1 plus mod W2. Let us see one example. So let the first word be W1 equals to 1011. Let the second word be 011. So then concatenation of these two strings is nothing but W1 followed by W2. So W1 is 1011 followed by, just write W2, 011. So and you can also verify the length. The length of the concatenated string is 7, which is equal to the length of first string is 4 plus length of second string 3. 4 plus 3, 7. So this is how we perform concatenation. The other operation is prefix of a string. So prefix of a string is obtained by removing 0 or more trailing symbols. So here we have an example also. Suppose if the string W is equals to ABC, then the prefixes of this W is only you can take as A, then you can take it as AB, or you can take it as ABC. So these are the prefixes of W. Suffix of a string, just opposite to the prefix. The suffix of a string is nothing but it is obtained by removing 0 or more leading symbols. For example, if we take the same string, that is W is equals to ABC, so then we are talking about suffix, right? So then I can only take C, or I can take BC, or we can take ABC. So this is how you can take the prefix and suffixes. And here we have one more definition, that is proper suffix or proper prefix. So this is nothing but a string W if and only if A is not equals to W. That means if I take a proper prefix, it should not be equal to the entire word. Similarly, if I take a proper suffix, it should not be equal to the entire word. So that, so based on that, can you tell me what will be the changes here? If I'm talking about a proper prefix for the word W is equals to ABC, what will be the proper prefixes? Somebody answer. I want to listen the answer from different people. If W is equals to ABC, what is the proper prefix of it? Yes, somebody has unmuted themselves. Okay. Abdul has given the response A comma BC. Very good. Either Abdul is answering, otherwise Malvika is answering. What happened to the remaining people? Not Malavika, Geetika, I hope. Hmm. So rest of you also be attentive and answer. Similarly, proper suffix. So in case of a proper suffix, the entire string should not be there. So that means ABC should not be there. Only C will be there, BC will be there for a proper suffix. Similarly, substring of a string. So here we have the formula for substring of a string. So that is, we will either you should remove one prefix and one suffix. A string obtained by removing a prefix and a suffix from string W is called substring of W. For example, the same string, let us take W is equals to ABC. Then I should remove the prefix, I should remove the suffix. Prefix A I will remove, suffix C I will remove. Then the substring is B. So here we have the formula also. Substring of W is equals to W minus one prefix minus one suffix. So these are the various operations that we can perform on a string. So now I want somebody to just list out the operations of a string that we discussed so far. I will choose the person. Sai Charan. Sai Charan. Sai Charan. Unmute yourself and just list out the operations that we can perform on strings. Sai Charan, are you there? Smruti, Smruti. I'm waiting for your response, but you people are not responding. Just list out the operations. So far, you are listening very concentratively. Geetanjali.
Length of string, concatenate, prefix, suffix, substring.
Okay. Length of a string you forgot. Length of a string. The operations that we have discussed are length of a string, concatenation, prefix, suffix, and substring. So these are the operations that we discussed: length of a string, concatenate, prefix, suffix, and substring. And we also have seen what is a proper prefix and what is a proper suffix. now let us see what is a language. First we have seen what is an
Madam, I have a doubt.
yes.
Madam, in the last substrings of a string,
Ah,
ma'am, you have denoted the formula W is equal
yes.
to W minus one prefix and one suffix.
Yes.
Ma'am, here W represents same or W represents different, ma'am?
W is the word. I already given the word, right? W is equals to ABC. So from this
Ma'am,
word, W stands for word or a string.
ma'am, here I have a doubt of ma'am, here W, we are calculating W, ma'am.
Yes.
So how we have we have value of W, ma'am? In W is equal to W minus one prefix and one suffix.
Okay, Abdul. You just see substring of a string we are calculating. That means
Yes, ma'am.
if I know the string only, I can calculate a substring. A part of it I can calculate. So that means I already have the W, right?
Yes, ma'am.
From this W, one prefix we are removing, one suffix we are removing. So then you will get the substring.
Okay, ma'am.
Okay. That's it.
Okay, ma'am.
Okay. So all these are symbolically given. Similar to mathematics, don't substitute as it is. Just follow it as a symbolical notation. Then you will not be confused. So now let us see what is a language. A language L over sigma. Sigma is an alphabet, right? A language L over alphabet sigma is a subset of sigma star. Sigma star is nothing but a collection of strings over the alphabet sigma. And phi and epsilon are also the languages. The language phi is undefined. The reason is it is similar to infinity. So the language phi is not defined yet, but epsilon is there. So the epsilon is similar to an empty box. So epsilon indicates a language without any string. So the language is empty. So far no strings are there in that. Okay, so now let us see examples for a language. The first language that we are defining is language L1. This is a language over alphabet 0, comma 1. And also there is a condition here. We should, the language, the strings of this language should contain equal number of zeros followed by equal number of ones. So we are starting with 0, 1, 1 0, 1 1. Next 2 zeros followed by 2 ones. Next 3 zeros followed by 3 ones. So like that you can define the number of ones. So here always we are following equal number of zeros followed by equal number of ones. So that is the language defined here. Let us see the example of one more language. This language is L2. So this language is defined over the alphabet. That alphabet contains symbol 0. So here we are starting up with a null string followed by single zero, followed by two zeros, followed by three zeros. Okay. So here we are allowing epsilon also because there is no such constraint which is stopping the null string. Suppose if you see the language L1, so here we are saying equal number of zeros, equal number of ones. If I include the null string, how can I say I have equal number of zeros and equal number of ones? So null is not allowed in language L1, but it is allowed in L2. So the conditions will be given clearly. So based on that, we will be defining the language. And one more example is language L3 is given. Okay. So language L3 is given. So this language L3 is 0 to the power of 1, 1, n, 1 to the power of n and 2 to the power of n. and here n value is greater than or equals to 1. So this is the language that we are having. So can you tell me what will be the strings of this language? Strings of this language, L3. Can you tell me the strings of the language L3? Just substitute the value for n. If I substitute value for n as 1, then what is the string we will be getting? 0, 1, 2. So if I substitute n value as 2, what is the language that I will be getting? Type in the chat box. If I substitute n value as 2, what is the string that we will be getting? 0, 1, 4. No. Okay, all different answers I am seeing. Majority of answer I am getting is 0, 1, 4. Okay. Okay, good one. So some students are also giving me the correct answer. Fine. So here in this language, 0, 1, 2 are the symbols that we have. So if you substitute n value like mathematics, 2 square is 4, like that we will not write. That indicates you how many number of symbols we should use. N equals to 2 means 2 symbols of 0 should be used, 2 symbols of 1 should be used, 2 symbols of 2 should be used. So the string will be 0, 0, 1, 1, 2, 2. So some of you have given me the correct answer. The correct answer is 0, 0, 1, 1, 2, 2. If n equals to 3, then 3 zeros followed by 3 ones followed by 3 twos. Very good. So now the operations that we can perform on a language are: first operation is clinic closure. The second operation is positive closure. So let us see what is meant by a clinic closure. Let L be a language over some alphabet sigma. The clinic closure of a set is denoted by L star, which contains set of all words over the alphabet sigma. So that means words of length 0, words of length 1, words of length 2, so on up to the limit. So that means you can express it as L to the power of 0 union, L to the power of 1 union, L to the power of 2 union, so on up to infinity. So which can be expressed as k is equals to 0 to infinity union of sigma to the power of k. The other name for this clinic closure is reflexive transitive closure. The other name for the clinic closure is reflexive transitive closure. Here we have the example also. Suppose if the alphabet sigma is a comma b and a language L over sigma is defined. So then what is the clinic closure of this is L star is nothing but L to the power of 0. L power 0 is a null string, right? A language with, so that means a string with length 0, that is epsilon. Next L1 is a string with length 1, so that is only one symbol will be taken, only A, only B. Next strings of length 2, AA, AB, BA, BB, so and so on. So and finally we will combine all these things. So that will form as the clinic closure. So if you see, L star is defined as epsilon A, B, AA, AB, BA, BB, so on. So length, strings of length 3 we have not specified. So all that you can take up to infinity, we can go on. So one more example also is given. Suppose if I define the alphabet S as a set 0. So this set is containing only one symbol, that is 0. So now S star. So first we should start with strings of length 0, that is epsilon, then strings of length 1, 0, then strings of length 2, 0, 0, then strings of length 3, triple 0, so like so on up to infinity. So this is the clinic closure of a string indicated with L star. So next we are talking about positive closure. So the positive closure of an alphabet is denoted by sigma to the power of plus. Clinic closure is indicated with star. Positive closure is indicated with plus. Sigma to the power of plus we are giving, and it is defined as clinic closure minus epsilon. That is set of all words over sigma excluding empty string epsilon. So if you take the same previous example, s equals to 0, so then the positive closure is, just I'll show you that screen once. So here I already have the clinic closure, epsilon 0, 0, 0, triple 0, 40, so on. So from this what I should remove? Epsilon, the null string if I remove, I will get 0, 0, 0, triple 0, 40, so on. So only the null string is eliminated. So remembering of these two notations is very, very important. Sigma star. Whenever you are seeing star in the power, that indicates clinic closure. That means you should understand that null string is also allowed in that particular set. Whenever you are seeing a plus symbol, that indicates a positive closure, which will not allow the null string. So these two notations are very much important throughout the subject. We will be using these two notations throughout all the 5 units. So be clear with what is star and what is plus. In other words, star means 0 or more occurrences, plus means 1 or more occurrences. So with this, I will conclude today's class. So if you have any doubts, you can ask me now. Today's recording I will be sharing you in your class group only. Today all of you join using the class code. I will post this recording as well as these slides in your class group. All of you join the